All right, we're going to talk about our last form, which is factored form. And so it starts off similar, y equals a, right? That a is going to be the same a we're familiar with. That's why we use the same variable each time, right? A means if it's still a, it's still telling us the direction of opening. It's also telling us how wide or narrow this graph is, right? In terms of that stretch factor. And then in this case, factored form tells us the x-intercepts. And that's going to be the values of m and n. Right, so notice it's x minus m, x minus n. Right, and this is the factoring we're used to. So if y is x minus 2 times x minus 3, then the roots, or zeros, those are those m and n values. So similar to when we found p, we're asking ourselves what follows the negative sign. And if it's x minus 2, then m is positive 2. And if it's x minus 3, then n is positive 3. Which means that those are what we call roots or zeros. That's why if you have a TI calculator, you hit the zeros button to find those x-intercepts. If you have a Casio, you're hitting the roots button. And those are just the x values. When we talk about x-intercepts, that's where we want to make sure we're talking about a specific coordinate point with an x value and a y value. So 2, 0, and 3, 0, rather than just 2 and 3. Right? They're talking about the same idea. We just want to make sure when we're talking about intercepts, those are points. When we're talking about roots or zeros, those are just the x values. Right? And notice on this graph, so we have a sketch of x minus 2, x minus 3. We see those x-intercepts at 2 and 3. Let's try a couple more. Find the roots of the following. So something can be in factored form for us. So here we have x minus 1, x minus 2. That means that our roots, right, or our x-intercepts are 1, 0, and 2, 0. Right? Or if I was calling them roots or zeros, we could say 1, oops, sorry, I won't put a comma there so we don't think it's a point. We could say x equals 1. We could also say x equals 2. Looking at the next one, again, we're going to be careful with the signs. If it says x plus 1, this is the same thing as x minus negative 1. Right? So we want to ask ourselves, because the form was x minus m, x minus n, what follows the negative sign? And if there is no negative sign, we'll create one. So in this case, one of our roots is negative 1, right? So the x-intercept is negative 1, 0. And then another root is positive 2, right? Just like when we found p in vertex form, we're flipping the sign. So C and D aren't in factored form yet, but we know how to factor. So let's do a quick refresher on how to factor this. Again, factoring is just being able to express it as products, right, multiplication, instead of sums, right, addition and subtraction. So I want to be able to say that x squared plus 3x plus 2 can be written as something, some binomial, times something else. Right? And if we kind of undo, right, if we reverse engineer what we know about expansion, we know that x squared comes from an x times an x. We know that 2 comes from a 2 times a 1. And we know that to get positive 2, I have two options. Either I can do plus 2 times plus 1, or I can do negative 2 times negative 1. But if we think about FOIL, we think about the way we distribute first times first, right? That gives us the x squared. Last times last, that gives us the positive 2. But it's those other two expansions, the outside, x times 1, and the inside, x times 2, that has to give us that 3x. And so if I have a positive 2x and a positive 1x, that's going to give me a positive 3x. So this is what we call factoring by inspection. And we'll review factoring a bit more in our next unit in RF2. But for now, we'll see what we can do. We've factored. Again, this looks like our factored form. We just have to be careful with those signs. Right? Because it says x plus 2, we have a negative 2. because it says x plus 1, we have a negative 1. When I look at D, the first thing I actually want to do is I want to say, do these things have anything in common? Do 2x squared, 6x, and 4 share anything? Well, yeah, I can divide 2, 6, and 4 all by 2. So I factor it out front again, right? I'm just writing it as a product. To do that, I'm essentially doing division. So I have an x squared, because I've divided it by 2. I have a 3x, and I have a 2. Now, this looks like something we've just done. Right now, I know that x times x gives me an x squared. I'm going to leave that factor of 2 out front, right? Everything is still twice as big as it was before. I have an x times an x. I have a 2 times a 1. And they both have to be positive to give me a total of 3 x's in the middle. So we have the same roots here. Notice that it looks different, right? But that's just the a value. Again, the a value has just told us how wide or how narrow this graph is. So yes, it's a little more narrow, but it actually still has the same x-intercepts. So we have a negative 2, and we have a negative 1. So let's find the equation in factored form given the graph, right? And as long as we have nice x-intercepts, this is going to work for us. So from our graph, we see an x-intercept, 1 on the left here at negative 2, and 1 on the right here at positive 4. So that means that m and n are those values, right? Negative 2 and positive 4. And then I know that my formula is y equals a x minus m, x minus n. So at least I know that I have x minus negative 2 and x minus positive 4. And then in this case, to find our a value, we look at the graph, it opens up, right? So we know that it's going to be positive. And because it's growing at a nice regular rate, right? As I go over 1, I go up 1. As I go over 2, I go up 4. As I go over 3, I go up 9. I haven't actually stretched this graph at all. My a is just a positive 1. So I have y equals, I can write the positive 1 out front or I can skip it. But I do want to make sure I simplify this inside to look like x plus 2, right? Because I was subtracting a negative 2. And an x minus 4. And so there's my factored form. Right, and here at the end is just a quick little reminder for how we can find some of these values in our calculator. So make sure you know how to do these, you know how to use your calculator. But that is everything we've covered in RF1, quadratic functions. Make sure you take the time to do some of those practice quizzes, test your knowledge, work with your calculator, learn those skills. And I'll see you in the next lesson.